Hi everyone, good morning, good afternoon from Barcelona, and yeah, welcome to a new Rhino User Webinar. This is Pedro here, and I will be presenting today this new video where we explore exciting workflows involving Rhino. In this webinar, Junghwo Park will be presenting the dynamic data interpolation using Rhino and Grasshopper between other BIM applications such as VisualARQ, Revit, Inventor, Solidworks, and Tekla. He will show different use cases in which highly segmented data are exchanged from the design to the realization phase. And well, Junghwo is an architect with a wide range of experience in architecture and industrial design. And he is truly interested in digital and computational technology. As always, during the presentation, I'll be covering the chat and I'll be collecting the questions for the Q&A session that we will have right after Junghwo finishes. So Junghwo, whenever you want, please.
Right. Thanks for inviting me, Pedro, first of all, and hello everyone. My name is Junghwo Park. I'm originally from South Korea, and I'm located in Vienna. I'm gonna share my screen and start to present. So let me know if you see my screen. All right.
Yep.
Okay. All right, so let's get started. So my name is Junghwo Park. I'm working at Group Ventures as a BIM lead, and I'm certified BIM trainer in Austria from Building Smart, and also BRE BIM AP certified BIM trainer. So my education is in architecture in Australia, and before I studied product design in South Korea and finished my master degree in Vienna. Right. Before I start, I would like to shortly advertise myself. So I have my YouTube channel called Point One Studio. You can find a lot of materials, especially used for dialogue and interview with other BIM expertise. And my company where I'm working is started in 1868. Very long history of company with about 8,000 people working globally. And one of the daughter company called the Store Makers dealing with lots of interior design and fit out, shop and detailing of all the furniture fit out and fixtures. And another sister company called Doka, probably you have seen many construction site, the formwork equipments they are supplying all over the world. And where I belong to is called Group Ventures. So we are doing research and development and developing different software for special BIM solution, and also as far as the mass production of precast elements and 3D printing technologies. You can see our company, especially is the event every 3 years happens in Munich called Bauma. So if you need more information about my company, you can also visit here and see. And we have here the archive of last year's Bauma event. So let's jump into my presentation. So as you know, today there is no way you can work with one software or like master builder as a master builder to everything from top down to finish your project successfully. So these days everything linked, and this is like very like small overview of tech stacks. And I center here why we should use Rhino as a bridge tool between many other applications. And as you can see, you know, Rhino can integrate with different programming language, and it can use the Rhino data, metadata, and link to 2D graphics or 3D CAD design. As far as BIM and facility management platform, because Rhino simply can modify complex data structure And for this reason, I would like to show today many use cases using Rhino and Grasshopper, particularly in between different BIM applications. And here, it's very typical, the diagram, how our industry works from, the conceptual stage as far as operation and end of building cycle, whole cycle, for specific project. And there are a lot of requirements from client side. And of course, our industry is highly segmented. That's the main difficulties. I would say a lot of people think, rocket science as a reference to something very difficult to achieve. But in my opinion, the building or construction process is even more difficult than, rocket science. Is because it reflects on environment and also the cultural perspective and all different national regulations. So previously, there are many intermediate Grasshopper plugins that offers Rhino metadata to use in BIM authoring software, but particularly for Revit. Revit is one of the, let's say, most well-distributed BIM authoring software at the moment. And as you can see, all those reference in the past was good workflow, but currently Rhino inside Revit offers really strong connection between Rhino and Revit, Grasshopper and Revit, and it's open source, so which means we can access both Rhino and also Revit's API in one application. And on top of that, Conveyor or BIM is also quite useful if you don't use Grasshopper. Those tools help non-programmers or visual scripting expertise can use Rhino, just pure Rhino, and use that Rhino metadata in Autodesk Revit, for instance. Or Speckle is another open source based on a Sava system that you can link many different applications. And recently, Autodesk Data Exchange is being developed quite quickly, and I'm going to show all this use case today. And lastly, the Omniverse from NVIDIA has a lot of potential. So if you look in the past, this is very early stage of Case Inc. The company is not exist anymore, but has a Revit plugin that we can upload or import Rhino geometry, and then it just create a bunch of points and as a grid structure and interpolate geometry in Revit from Rhino input. In this case, there are some mathematical difference between Rhino and Revit, and the geometry is not 100% perfectly aligned, but still it was the one of the options we could use back in, let's say, 2011 to 13. And then the Dynamo is appeared in Revit's plugin, and there are tool called Rhino was as an additional package developed. So for example, we have here Rhino 72 surfaces that could be read by Dynamo, and then we can use this geometry for Autodesk Revit, for instance. But all this history is not anymore useful because the development was done very quickly. And I'm going to show the use case today. So if you look at my contents, I'll try to shorten within next 45 minutes, but I prepare quite a lot of contents. If you look, I'm going to show here, for instance, how SolidWorks model can be used in Revit throughout Inventor, and then we simplify geometry in Inventor using Rhino inside Revit and converting as a native Revit family. That's one of the topic. And also, if we have a building design, how can it be used for structural engineer using sophistic and of course Rhino is bridge tool to connect them, and also bridge use case or reading the result from structural calculation into Rhino and display in Revit. And also we have civil and civil model as use case. In this case, I use particularly VisualARQ to use Rhino geometry and information to export as an IFC. And I'm gonna a bit criticize about IFC model, which is not perfect for different applications. And for this region, I think Rhino is really great tool to bring different geometrical input information and also non-graphical information to interpolate these metadata to other platforms. And then I'm going to show all these kind of complex pipeline just simply using Grasshopper and Rhino and VisualARQ, and yeah, also Rhino inside Revit, and we can convert all metadata as an IFC model. And after that, our colleague from Doka, Gerard Schindler, will have some use case of Formwork, how standardized Revit family can use visual programming to maximize the efficiency and also to calculate the quantity of Formwork equipment. And then yeah, I'm going to move on from another colleague, Tobidas from Doka US. She's gonna show Grasshopper is integrated in Tekla Structure, and short presentation how we implemented this workflow. And then the next slide is we don't want to limit all this data interpolation not only for geometry and non-graphical information, but we would like to also showcase graphical information, let's say the textures and the simulations, how it can be interpolated and shared in different applications. And for this use case, we are developing our own organization's virtual space, or in other words, metaverse prototype. And for that we use Speckle quite a lot. And then the other modern methodology using metadata is called Autodesk Data Exchange, and maybe some of you already tested it with the ACC viewer, and that I'll shortly demonstrate. And then eventually the Omniverse has huge potential, and that's kind of contents for today that I'm gonna share with you. All right, I recorded most of contents, so I'm gonna just play and speak, and just let me know if you have any things, difficulties or. So in this case, this is the actually SolidWorks model that used for whole Bureau of Quantities, and I found SolidWorks model can be very easily import in Inventor, Autodesk Inventor, and then this Inventor has a good connection to different BIM applications. For instance, here we can set local origin, and then all these kind of parameter we get from SolidWorks, we can convert it as an Inventor and then bring it to Revit. In this case, we don't need Rhino at all. We can just use native tool from Inventor. But of course, there is problem. So let's have a look. So this is the result that we export from Inventor as a Revit family. It does bring good geometry, and also all this non-graphical information is bring it here. But unfortunately, that there is no option you can, as a designer or planner, can modify this family in Revit. As you can see, all the geometry that once I exploded it, it somehow join all the parts. So my argument is that, okay, that is maybe a quick and dirty way to bring Inventor model or SolidWorks model to Revit. But the more efficient way, if I am showing here using Rhino inside Revit, has really good pipeline here. So I'm bringing the Inventor model as a step file in Rhino, And then you can see using Elephant plugin for Grasshopper, and we can mining the different parts of this assembly model. And we can also read all the metadata from the data set from SolidWorks. So this metadata can be linked from Excel spreadsheet. And what is good about Rhino Inside is it's a game changer because we can set even native Revit materials directly from there, and you can see we can automate all this process to generate a bunch of material for the Inventor output. And then eventually, if you're familiar with Revit, you can make it as a shared parameter and then use this all information for Revit family. And now you can see here we have native Revit family with all the metadata embedded in there as a native parameter sets. And you can also go in the family editor, and when you look at in the family editor, all the parts comes, like which can be editable for each designers or planners. And yeah, subcategories, everything is automatically comes in Revit. But in this case, we haven't, optimized the geometry. It's too much detail. So if you need really this higher level of detail, we can use the same process. But otherwise, I would recommend to use Inventor. Has really good built-in engine to simplify the geometry. So in this case, we're going to use Inventor here, the simplify tool. And here, if you type, for example, the certain range of dimension, it filter out the parts that you want to exclude from the geometrical export. You can also, some of the geometry which you don't want to exclude, you can include it by clicking those parts so that, we can control like which one is going to be excluded and which one is going to be included. So for me, in this case, just exclude all those hardware and fitting parts. And then I'm happy with it. And you can also control like in terms of hole or fillet chambers, all this kind of detail from there and give different range. And eventually you can export that as a geometry. But here also we can remove all the internal parts. And then once you're happy with it, you can export. And this geometry can be, all these parts in this one assembly file can be exported as a all separate part and step file format. You can bring into Rhino. And in Rhino, you can do more precise model check. And when you think this is perfect for Revit native family, then again, the same process we did. In this case, I'm referencing all the BREP geometry from Inventor and then bring it to, Rhino inside Revit. And just once you have this pipeline, a script is prepared, and basically we can just produce like thousands of assets as a native Revit family. So this is the result. Of course, in this demonstration, I didn't really assign any object styles or the materiality, but that can be done fully from Grasshopper, or your Revit expertise can do within Revit, however they like. But the geometry is very optimized. The next use case is to show how structural calculation software such as Sophistic can be used in Rhino using Grasshopper. And then we'll also look at Rhino inside Revit to produce a complete set of model in Revit. So Grasshopper offers this data output, which you can streaming the Grasshopper outputs, and using data input components, you can bring all these, let's say, design scripted elements into specific calculation software, such as Sophistic is in this case. And I'm bringing the geometric output and all this data which was output from previous design script now can be simply linked to, let's say, sophistic Grasshopper plugin. So you can see foundation slab, floor slabs, and core walls, and all these structural elements. They can be applied as analytical model. So you see the members and analytical surface now converted to sophistic readable geometry. And this metadata can be exported from Grasshopper. I mean, just stream out from Grasshopper. And in software like Sophistic, you can simply, reference this metadata and then simulate your calculation directly there. And this has a lot of potential because as a structural engineer, you can ask architects to share the design script and then maybe modify a bit, and you can instantly revise the design changes. So in this case here, I'm gonna just change the some design parameter here, or this twisted slab profiles. I'm gonna move somewhere. Maybe that's too high, and so we bring it down a bit. And then accordingly, yeah, the whole design of architectural scheme is changed. And sometimes, you don't have to script everything in Grasshopper. For example, those diagonal members are difficult to program it to match perfectly to the slab changes. And in this case, we can use the attribute of Rhino and reference those attributes automatically using Grasshopper plugin called Elephant. So what I'm gonna do is just showing this use case. So we will bake those straight columns and diagonal columns. And then this baked geometry in Rhino from Grasshopper has attribute from this Elephant. Now, I'm gonna show here, for instance, enable a preview of slabs. And in Rhino, without just creating your complex visual programming or scripting, you can just simply model how you think it makes sense for your structural design. So yeah, I'm just selecting the slanted column layer, and then starting to, design the structural element as a structural engineer's eyes. And yeah, that's the easier process than completely making it sometimes from the script. So this is the somehow, yeah, I'm gonna skip a bit of the process because the time is too. So imagine that you complete the new design of diagonal slab, and that can be referenced from Elephant, and then your data output components will update the output file automatically at the same time, and your input components will read the stream data at the same time as well. So this is the whole workflow, and what you need to do in structural engineering software is just simply calculate once more all these metadata, and then you have updated, analytical model, and there you can simulate all kind of design code you need to do for structural engineering. And so far, this is just between design script and structural calculation work. But many case in practice, all this structural calculation model is very difficult to document in BIM authoring software. But since Rhino Insight offers very good connection, now I'm just gonna again reference this data output from design script, and then this time going to use Rhino Insight components, and we just gonna generate first of all, like, the levels, and then basically all the other structural elements you can generate it from the Grasshopper. And of course, sometimes you may have to think is it better to use adaptive components in Revit or cut and wall? I mean, this is all depends on how far and how much you want to detailing it. But yeah, that's the simply you can instantly generate this construction model in Revit. And also the result, that usability of result is sometimes you know, you want to visualize those kind of structural analysis in Revit. Previously, it was never possible, but yeah, it's also possible. I'm gonna show that use case later. And in this case, it's bridge construction, and again generated from sophisticated Grasshopper plugin, which allows us very flexible, you know, bridge design, and also we can calculate all these bridge analytical components or elements directly from sophisticated. And the next challenge is how we're gonna bring this to BIM application. At the moment, I'm showing most of use case in Revit, but certainly all this pipeline or workflow is possible with, you know, Tekla or ArchiCAD, different BIM authoring software. Grasshopper offers all these connections. And right now, I'm just gonna convert all these static elements in Revit from the Grasshopper outputs. So you can see we have cross sections of those bridges, and also the tendons, the cable center line, and also pier center line, and also bearing points, and also support condition, where support condition should be, and all the annotation parts. So now, yeah, the same story, we created material, and then using Rhino inside Revit, you can generate all the loadable Revit family as a part. So, you know, Revit has the new category for infrastructure since, I don't know, since 2022, maybe 23. And all these components can be assigned to infrastructure element. So that's the whole story for, you know, bridge case. And yeah, if you need to look for more information, Sophistic homepage has really good example file you can download and practice. And yeah, that's very difficult to achieve in Revit without using visual programming. I think you can use also pure Dynamo, but Dynamo, its geometrical operation is a bit slower than Grasshopper. And this case is again previously mentioned. You have that analyzed from calculation software, and then you can stream those output result from your structural report, and you can stream the coordinates and different numeric attributes as a variable. And you know, if you have generate Excel sheet, you can also read in Grasshopper. This is very typical Grasshopper data interpolation. But what's nice about Rhino inside Revit is that even this kind of graphical preview from Grasshopper, we can display in Revit. So, I mean, sometimes maybe it's not necessary, but it's also nice to show this kind of graphical representation from your static result directly in Revit, and you can, you know, put in your title block or document it in further. So in this case, if I just click on the mesh density is very high, but I'm gonna disable it and show the actual graphical view in Revit. Let me just keep a bit of the time. Sorry, I went too far. So as you can see here, yeah, when you set the preview for Rhino inside Revit, you can, you know, show that result in Revit interface. I found this really good. But this is just exactly same as Grasshopper preview. You know, the color code or color legend showing in Revit background. Next use case. This project was quite complex topography work I have to deliver, and this contour was generated using Grasshopper and bunch of point coordinates. And then you can see here we have to calculate between existing topography and new proposed subject site. I have to calculate every single earthwork so that we can track on the quantity of on the realistic construction scenario. And here the building is suit on the topography. And if you look at here, Rhino, a lot of people think Rhino is CAD software, but if you use cleverly, Rhino it's a BIM software. So in this case, VisualARQ was as a plugin was used, VisualARQ, and which we can even populate different parameter that you can use it in Rhino, and eventually you can export as an IFC format. So all these different earthwork, you can see how complex it is here, and these layers and layers of different soil model. And when you see more in detail, this kind of very precise model is very difficult to model in many other BIM authoring software. So I found Rhino is very flexible, and you can really model all kind of scenario. And yeah, if you needed the non-graphical information, just provide it in Rhino geometry, and then eventually you can use Grasshopper or just simply use IFC export from this VisualARQ plugin. And this red part is, for example, how much I cut the soil. And if you look at the information of the this digging part of earthwork, all the volumes and classification is classified in the Rhino model. And now I'm gonna show later, very soon, the beauty of this let's say organized or structured data as an information, and we can use it in the all kind of BIM application using IFC format. So yeah, I don't know, this kind of model is maybe too crazy, but you can simply achieve in Rhino. And here in Solibri, if you display and make a quantity takeoff, and you can classify or the volume of geometry with information from your classification, and this helps a lot to compare with bidding documentation. So this is one of the other use case I was mentioning. And my discovery is that this VisualARQ IFC exporter works really, really well. So highly recommend to use for your work scenario. So let me skip. And also in terms of documentation, the section tool or plugin from Rhino, of course it works quite dynamic, but still I prefer to use VisualARQ documentation tool. Just crop the view and look at the sensitive modeling parts that you can go through. But I think IFC is still not perfect. Here, this is the IFC model from Revit, and that we can bring into Rhino. And you can see IFC model always have some geometrical problem when it comes to, it works quite weird actually in different applications. So here I'm just gonna show, we have here Revit native elements has different level of detail is set for each family. And if you look at the detail of that, we have here coarse detail elements that can be visible, and medium and fine detail. And the problem is, even though we set these coarse detail elements, that is not exported as an IFC. And when you open or import in different applications, unfortunately, this is still appearing in, different application, or the corner where it's supposed to be cut is not perfectly cut geometry. here is Bentley Open BIM Open Building Designer, for instance, and it works quite well in terms of opening area. And here is ArchiCAD view, the same IFC model. But as you can see, the course field is still up here, which is annoying. And another demonstration, this is my master thesis project, has a lot of complex geometries linked in Revit. And if you think about that complex geometry, IFC, you can always encounter with this kind of error from Revit. I don't know if they fixed in current version of Revit 2024, but I guess when it comes to this kind of complex geometry, it never really works well with IFC exporter. And yeah, it's not only Revit's problem, it's most of BIM authoring software's same problem. So what Rhino Insight helps in this case, that I can classify and categorize all this kind of geometry and then bring into Rhino as a Rhino native geometry using Rhino Insight Revit again in this case. And then because Rhino read all this geometrical context in a very precise way, and I can, you know, first of all, this is the data transfer from Revit model to Rhino. And let's imagine this model need to be reviewed by BIM coordinator. Maybe a lot of BIM coordinators or BIM manager doesn't really use Rhino, maybe. In this case, we can open this Rhino file in Navisworks. Yeah, in Navisworks, and many BIM authors or BIM coordinators, they have Navisworks as one of the major coordination tool. And Rhino file open perfectly in Navisworks without any geometrical error. And now here in Navisworks, I use just IFC exporter from Navis tool, and you can classify all kind of the IFC entity, and you can also populate different property sets, and you can map the properties. And then when you export this new mapped IFC and open in one of the IFC viewer like Solibri, you can see very well structured the IFC model, which has very good category, and all the metadata is embedded, how you want to use. And this is like kind of re-engineered IFC model using Rhino and Grasshopper. And this demonstration is a little bit more complex, but I want to test in this use case how Revit model can be, packaged as a property information using Dynamo. So Dynamo, what is interesting once you use Rhino inside Revit is that not only just the API, you can use, the Grasshopper and Dynamo at the same time in Revit, which I think is really powerful. If you use both visual programming tools. So all the Revit ID and the group of parameter set is exported from Dynamo, and we read this non-graphical information through the Excel datasheet. And using Rhino inside Revit, I'm just gonna, just reorganize this metadata, and then again we will read Revit's geometry using Rhino inside into Rhino, and then we're gonna populate all this metadata as an attribute in Rhino. So this is a bit of steps, and let's just jump it because of the time. So here, particularly, I use VisualARQ again because it has really strong the dataset generator from their components, and also we can assign as an IFC element. And when you look at here, all these referenced and converted Revit geometry in Rhino, with all this data set from Revit. And Rhino contains all these Revit parameters as a native Rhino elements. And imagine this metadata can be, or property sets, let's say, can be exported as an IFC model. Then you can use Rhino as a full BIM software actually. So here in my demonstration, I'll just look for the Revit ID from Rhino geometry, and it matches perfectly between that word or this word, for example, has Revit ID, and then and then this let me think. Yeah, and then there, because we are duplicating the geometry and the grasshopper components, for example, human, and we can delete the certain element in the layer, and I just duplicate the elements from the Rhino viewport, and then we assign again all the parameter property set into Rhino. So in this case, slab that is baked, and when you look at the metadata, the old Revit floor slab information is included in the Rhino geometry as an attribute. Right, let me skip a bit. So I did it same process for the roof, and then yeah, I'm going to do one more operation, because Revit, when you have this complex level structure, sometimes it's very difficult to export right IFC building story structure. So what I'm doing here is referencing the Revit, the Rhino attribute. For example, IFC root description as one of the main key value. And I would like to restructure the IFC building story in Rhino, so we can have a very articulated building levels in IFC structure. So here I'm just, because all the metadata is embedded in Rhino geometry, I can search for this key and then the value, for example, level 1, all these are level 1. I assign as a level 1, level 2, and 3, and 4. And because of that, now these IFC levels building story is reassigned, and we can export this level structure as an IFC using VisualARQ, and this can be read in for example, Solidworks. So you see we have very structured level, and that can be achieved in Revit. But in Revit, if you have this kind of overlapped floor level, you will never get that good IFC level structure unless you split the wall and constrain to different levels, but it's a lot of work to do it. So this is another benefit of using Rhino and Grasshopper. So let me move on, and just to the next topic is from our colleague at DOCA. We have very standardized the Revit family that can be easily explored with using VisualScript and generate bunch of those families according to this complex slab geometry. And Rhino Inside was being tested in from DOCA's colleague here, Gerard Schindler. And as you can see, when we have structured information as a Revit family, we can maximize this automation process. So this many formal equipments, actually these is very time-consuming
Hello,
work.
I'm Todd with Bakas.
And then that just populated very quickly in Revit environment. Sorry, I'll go back my slide a bit so we can review a bit. Yeah. And every single this adjustable floor props has different height, which is crazy work to do. But with the help of Rhino and Grasshopper, with Rhino Inside, you can populate these many adjustable floor props, at one button, and it's very, very efficient. And next slide, my colleague from Tobidas from Doka US going to show another workflow using Grasshopper in Tekla Structure.
Hello, I'm Tautvydas Bakas, BIM coordinator in Doka.
By the way, can you hear the sounds from my sharing?
Yes.
Okay, thank you very much.
USA, and today I want to show how we're using in our company Grasshopper Tekla Live Link, and especially Grasshopper component, which one you can find in Tekla Warehouse. So let's jump to Tekla. I prepare a few examples. For today, I will show our MF240 climbing system. And to insert the Grasshopper first, we're using polybeam. So let's snap very fast edge of a wall. Where is my first bracket? Where is my, let's say, second bracket? And the end middle mouse button. I just get a polybeam and I come in here. Where is Grasshopper? Double click. And to choose Grasshopper scripts, I can click three dots and find MF240 here. And let's wait a few seconds and it will load interface here. So to place this one, I click here. You can see pick a beam. So I just choosing this beam. And in a few seconds, I will get my brackets. The really nice thing about polybeam insertion with Tekla direct modification that if I change, for example, to 6 feet, you will see that in a few seconds, my bracket is adjusted. And let's show maybe one more example with this example. So let's go here to vertical railings and let's choose different railer here, this vertical one. So you see in a few seconds, it's also adjust and make smaller. Next step, let's place platforms on top of that. And let's wait a few seconds until we get interface. That's a bit simpler one. So let's trigger Grasshopper one more time. And in this case, you will see that here is pick a component. So I just need to choose my component, the Grasshopper component. And in a few seconds, I will get all three of my platforms here. And of course, you understand that if I change my, let's say, beam, the platforms adjust. First, of course, bracket, and after trigger platforms, and it's also adjust. And the last example, what I have here for a map is scaffolding bracing. Let's wait a few seconds, trigger one more time, and you will see in this time is Tekla polyline. So let's choose one point. Let's choose another one. And also let's go somewhere up. Let's say somewhere here. I'm happy with that. Middle mouse button. In a few seconds, you also getting this bracket here, well, scaffolding bracing, sorry, with all right position and adjustment, which manually it will be not so easy to do. So that's what I want to show today. You can see that performance of Grasshopper custom component. It's really nice and especially big advantage if you don't have a lot of good users who know how to use Grasshopper Live Link. Thank you and have a nice day.
Special thanks to Tobidas from the Doka US. And yeah, here also I want to go as far as visual interpretation of the BIM model. How can it be, the whole this data can be shared using Speckle. So in this case, we used multiple applications to design our metaverse project. And this project was deployed in our server using different script and package of softwares. And as you can see, it's fully web browser accessible through web browser. And you can also get into inside the building, and basically we can showcase all this kind of sorry. And also the Rhino is used for main design tool to develop such complex, and the geometry is very complex, although has also many baked textures and lighting from Substance 3D. We could use this Speckle as one of the main communication tool to coordinate with the visual artist. And I want to show a little bit more in detail that I prepared, but unfortunately the time is ticking, and I think I have to close my presentation from this far. But basically, Speckle has a really good integration. I'm very looking forward to see more development from Speckle side, the integration with different platforms. And another thing is very powerful if you use Autodesk ACC viewer as a main CDE tool. You can think about Autodesk data exchange application that bring whole different applications, geometry and non-graphical geometry, and then this metadata can be shared. So if you can see here, all the Revit parameter comes as a Rhino attribute, and then you can keep working on it. And also Omniverse, that is all this kind of different work. Eventually, we want to move further to VR, AR, and the metaverse, and Web 3.0, and also digital twin or machinery. So this kind of the coordination can be achievable with the Omniverse. And I think that's all for my presentation today. I'm sorry that I have to hurry up at the end, but I think it's kind of a good set of information. You can think about how the metadata of different application can be used using Rhino and Grasshopper interface. And if you have any question, I'm happy to answer.
Thanks, Junghwo. Wow, congratulations on such an amount of samples and use cases where, well, Rhino can be part of these complex workflows. So yeah, we have some questions from the audience. So let me read any of them. So can you export Rhino geometries to IFC through Rhino Insight, or can you export IFC through Rhino Insight Revit?
Yeah, so Rhino doesn't have native IFC importer and exporter, but you can bring all your Rhino geometry in Revit or ArchiCAD or Tekla, and those becomes native elements of each BIM authoring software, and those BIM authoring software has good feature to export IFC. So you can just use Rhino, still design or documented Rhino, but eventually you can convert it to those BIM authoring software using Rhino Insight, and then export from there directly. That works perfectly.
Okay. So Castle Chan has another question. I see you use VisualARQ to export to IFC. Does the exported IFC contains artifacts when exporting huge models?
Yeah. So VisualARQ, of course, there are a bit of problem when it comes to huge, but so far I didn't see a big problem from VisualARQ to export as an IFC. But there are some issue when you import IFC in VisualARQ using in Rhino environment. For example, window opening when window openings are polygonal, and it just comes as a rectangle opening. But this is the minor issue. I think VisualARQ team is working hard to fix it for the next version. I hope.
Me too. So Ben Fruling has a couple of questions. The first one is, does Rhino inside Revit Grasshopper have the ability to grab the UID and assign information based on these keys?
Yeah. So that's this. For this reason, I used Dynamo because I didn't want to use Revit API in Rhino inside Revit. But you can go to Revit API documentation to bring all this ID information in Grasshopper. Otherwise, Dynamo has all these components that you can read. And in my case, I just stream that information as an Excel file and then bring into Grasshopper and read it there to populate all the information in Rhino.
Yeah, and the second question, does work sharing in Revit break relationships when bringing data back and forth into Rhino Insight?
Sorry, I didn't get to. Does Rhino Insight graph ability? Does work sharing in Revit break relationship? Okay. So when you're working in the work sharing environment, it's even more powerful, I have to say. So it depends on how you're gonna lock the mechanism of, between the colleagues, and it's in work sharing environment. But if you block, synchronization time and this kind of documentation manage time to synchronize your local file to central model, imagine all this script can be used for multiple users, and then your central model update at the same time. It works perfectly.
Okay, so Laura Milner is asking more videos about your Rhino inside Revit and Grasshopper workflows.
Yeah, so I have a couple of videos that shows in general in my YouTube channel. If you come to my channel, there are many other more in detail. Sometimes it's too long, but you can watch them. Or I'm actually training Rhino inside Revit with McNeil Europe's workshop I do once a year. But next month, 13th to 15th of November, I'm running another workshop with McNeil Europe, specifically focused on structural engineers this time. But there I'm gonna show a bit more in detail in terms of Rhino inside Revit. So if you guys interested and if you're a structural engineer, please join the workshop. That would be great.
Okay, Junghwo. Well, thank you very much. I think that we are running out of time.
Yeah.
So, well, thank you very much for your effort and for your presentation.
Thanks, Pedro, for the invitation, and I hope I didn't bother you too much for long presentation time.
Nah, no worry. It was fine.
Okay.
It was fine.
Okay.
And to the audience, let's see each other in the next video.
All right. Thank you.
Okay.
Then have a nice day or a nice evening, Rian. Bye-bye.
Thank you. Bye.